At LSI, we don't just follow trends, we help shape the future. Welcome to Behind the Win, the podcast where we break down the biggest moves in tech, innovation, leadership, and government contracting. Here at LSI, we're bringing you exclusive conversations with the minds behind groundbreaking advancements, disruptive strategies, and industry-defining wins. From retail to tech, defense to government solutions. This is where you get the insights to stay ahead. Let's go behind the win.
Okay, hold on. Welcome to Behind the Win, where we go deeper into how visionary leaders are shaping industries and communities. Today, we're busting the biggest myths about nuclear energy, from safety to cost and why it could be a quiet engine for American jobs, especially across the West. We'll share how our team helped launch a new association, bringing utilities, tribes, manufacturers, universities, and communities into the same room. Josh, welcome back. Let's dive into some of this nuclear stuff. So first and foremost, what is nuclear energy in plain English?
Nuclear energy is the ability to bring reliable, clean energy to power communities across the world in this day and age when we need more energy, we need more reliability, and we need it clean. And nuclear is something that people have spoken about for decades, and we are living in a nuclear age. The issue right now is how do you take what we've learned from those big projects that people, in many cases, are aware of and may be scared of, to bring them into a smaller, safer scale, which in many cases is now known as these small modular reactors that can be moved and placed in locations across the world at a price and size that we haven't seen in ever.
So let's talk about that a little bit. Why does nuclear energy get a bad rap?
It gets a bad rap that it was such a practice decades ago, and there were some issues associated with safety that people, rightfully so, were nervous about. Should this be in my backyard? What are the impacts? What's been interesting, though, since those early days, things have changed dramatically. Many of the facilities across the world are operating safely and have improved the situation, which going back decades wasn't as strong as it needed to be. But those issues, the safety issues, have been resolved. And to this day, we are operating many nuclear facilities across the world in a safe, reliable manner. The issue has been these are very large scale. They're very expensive to operate and maintain, and they aren't necessarily addressing the needs that we're seeing moving forward.
So I think too is that's pretty, it's for those of us who are uneducated, right? Prior to coming to LSI, I think when I heard nuclear energy too, people just go to thinking of like the nuclear bomb or something nuclear, right? Nuclear kind of has this connotation of it's the end all be all, but it's not great, right? So I think you're just saying it's people need to be educated about what nuclear is. And maybe that's telling them, why do we call it clean energy?
Yeah, and I think it's the process. And again, the challenge is always when you do something, you do it well, and then there's a safety related issue that arises for whatever reason. How do you overcome that? And what's been interesting is that we've been decades talking about this and decades of safe facilities around the world operating in many of our backyards, and we don't really think about it because they're safe. However, getting over those initial issues that arose, such as what you described, the phrase nuclear has so many different connotations. How do you ensure that when people hear nuclear, that they are starting to see it as reliable, clean energy and not having this idea that it's something in the past that may not have been safe for a variety of reasons or had an issue for other issues, but recognizing it's happening everywhere in the world right now. And how do we get over that, I'll say, hump to make these more acceptable, smaller in areas where energy is really needed in this day and age?
What's a small modular reactor? You mentioned those. What is that?
Yeah, it's something in which people have been experimenting in for decades. And it's basically a smaller facility that takes up less land, takes up less water, takes up a variety of measures that make it modular in some ways in nature to move it around to different locations or to build it in a facility which then can be moved to other areas and smaller in scale. So you think about the construction cost of large energy projects. They're massive. And when you start talking small modular, you're not talking a capital intensive project. You're talking something that could be built off site or the components built off site and moved to a location where then it can be developed and executed in a way that is safe and reliable in a community or in an area that really needs it.
So, and can you give us a scale of with nuclear energy, what can it produce? How much of it can produce so much more than what our typical energy usage is today?
So when I say small, you're generally looking at us facilities that can handle a community of, let's say, 200,000 people. And that can go smaller and slightly larger. But as you're developing, larger energy facilities, you might be joining more of these together. Or
And is that thought that it's just cleaner for our environment, that smaller modular reactor can give power to an entire, like you said, 200,000 community, and it's cleaner, costs less, more effective?
Yeah, the intent is that it will do everything you said. The challenge has been over the past several decades, how do we do it and ensure that we're doing what we say? We're making it smaller, we're making it modular, we're making it safer, we're doing all these things. And really, no one has perfected it. And what's happened is you have a lot of folks who are innovators in the area, and they've developed an idea, and in some cases, developed a prototype. And when they try to scale it, the price increases, or standards come out or different entities come out and argue that we need to have the following in place. For example, let's say that you're just building a facility that is, and I'm going to use a bad example, but in a home where you have someone that comes in and just builds the place unique to that place. Then you have these modular homes coming in. And we know exactly all the specs of that modular home because it was built in a factory. It was built to a degree in which it's completely to scale with what's needed. It doesn't have a half an inch protruding. Let's say that now you build a facility that's not modular in an area and you get through it, and then the inspector comes and says, by the way, you said you were going to use 16 feet of cement and you use 16 feet and a half, or 15.9. That doesn't pass. But you've invested all this money in the infrastructure because it's a one-off facility that now, because of what was required from going and checking it, it doesn't pass. So it sits again and it adds more cost. And so it's not that we can't develop these. It's just that as people do it, they start to focus in on things that as they narrow in more on it, the cost keeps going. And we saw that in the state of Utah, where initially one of the projects they were looking at made complete sense on paper and complete sense as they were developing it. But every few months they would come back and say, oh, by the way, there's an added cost to this, another added cost, to the point where those who wanted to buy it are like, why would we buy this when it's twice, 3 times, 4 times the amount that we'd anticipated, and you still haven't built it? So that's been the challenge, is that, not to say there aren't these creative minds, it's how do you get these creative minds to be able to focus on developing something that can be done in some ways, I don't want to say exponentially, but in ways that you're producing hundreds, not one-offs.
Well, and Utah's moved to, it's one of the several states that are putting a lot into nuclear energy and, the ecosystem of it. And I think what we've learned in the last little bit, and we'll dive into what the association, we've created later on a little bit, but is that what's crazy to me is that they say like solar and wind turbines and all these things are great, but they're not really moving the needle, and they're actually worse for the environment. The real only true way is through nuclear energy.
Well, what's been great, and why I think nuclear, we hear this renaissance of nuclear, is you now have folks who in the past may have drawn conclusions that it's not environmentally safe. And as they've studied it, particularly in the tech sector, they realize it is environmentally safe. So some of the biggest pushback occurred within communities where the tech community where they were concerned about safety. And at that time, in many cases within the tech industry, they really liked the idea of clean renewable energy, which we all do. They focused a lot on solar, a lot on wind, and did this for years. But when we look at what's needed for the amount of energy required, those can't meet it. And so with this push of tech now saying we need it because we have this infrastructure that needs to have
Whether it's
reliable
AI
energy.
alone.
Yeah, AI, I mean, just AI alone,
Mm.
the amounts, and at some point someone's going to produce some sort of technology that will reduce the amount of energy required for our systems, et cetera. But in the meantime, there's not one tech person that I know that is not saying we need to have a new approach to how we provide energy to the facilities we know we're going to need up through 2050. And it is massive, the amount of energy required, not just in the tech sector, but across all areas around the world that need to have a reliable energy supply that you can bring is always on. It's not as though you're having to, giving you an example, if it's a hydro, well, if the water's not running, the hydro's not running. Or if
Yep.
there's issues associated with environmental issues with water, it's not running. And the same with solar, the evenings. Well, battery storage. Well, then you're talking again, all the developments that are needed to
Right. The
ensure
equipment's
battery.
outdated from the time that you've actually paid it off type thing. Yeah.
Exactly.
So let's educate listeners a little bit more. We're going to play myths versus facts. So the myth is nuclear isn't safe. What's the fact?
Fact is, around the world, people are powering their houses, communities, industries with nuclear power. In the United States, a large percentage of our power is nuclear generated, and in some countries, the majority of their power is nuclear. And these are plants that are operating safely, but they're not small modular. These are large facilities which have been around for decades.
And I think those are the ones that kind of bring that negative connotation, right? We're not going to name some of them, but there's some of them out there that they have them, the reactors are gone bad or, things like that. But I think also that's continuous improvement, right? We've got to have some of that failure so that they could pick back up, fix it. And you know what I mean? It can't just ever be perfect out the gate.
Yeah, and unfortunately, the plants are operating very safely across the United States. I'll speak to that audience, and they are continuing to improve the processes associated with those large facilities. But in the end, these are large systems that you just can't pick up and move to other areas and have a very fortunately, a very strong standards associated with them that they are continuing to improve and ensuring the safety so that we don't have situations that occurred decades ago that people still think is occurring nowadays, which it's not.
Okay. Myth, nuclear waste is an unsolved problem. What's the fact?
Well, look at around the world. I mean, we have this type of waste or arguably this type of fuel that's been spent moving around us all the time, and there haven't been issues associated with it. And now powering facilities with different types of the energy needed to power it, or the inputs required to power it, we got to make sure that there is sufficient amounts or alternatives or new types of fuel required. And that's something in which is what we're looking at addressing in the association as well.
Okay. Myth, nuclear is too expensive and too slow. What's the fact?
I'd say a little both. The older systems to build large nuclear facilities, yes, they are crazy expensive, and there was an awareness that they needed them, so they were built. Nowadays, with the small modular, the intent is to make them reliable and cost effective. The challenge has been,
so we're not trying to make one that does the entire state of Utah. We're trying to make one that can maybe power a few counties and then another one to do other counties. So just scaling, I guess, decomposing it a little bit down to a smaller scale.
Yeah, making these available in a way that you're pulling, and I'm going to simplify it in a way that is probably, hopefully for the listeners, is that it can be built off-site to all the appropriate standards and has a ecosystem of supply chain that can feed it and nourish it and ensure that it's there, and that you can place these in locations and not worry about this becoming a large infrastructure project because it's modular in nature and can meet standards in factories where all of the issues associated with the safety and durability are met. And so, but the issue associated with that has come down to cost as well. These are not new ideas. And when we really put it to the test, we have found that the innovations have been lackluster in some ways because of the cost associated with it. Not that it can't be done, the cost associated with it, or how do you ensure that you can create these in multiples rather than just one-offs. And so, the intent is that we can get to the point where these just become off the shelf in many ways, and that the supply chain is off the shelf. We're not close to that at this point, but it's the direction that many are wanting to go.
And we talked about this in a little bit. This myth is we don't need nuclear because we have wind and solar. And I think that's just the fact that it doesn't produce the amount of energy that nuclear can and the scalability, and that it's actually, we've talked about a few things, right? Outdated at different times. And it's just, what are some other, facts around that when people think we don't need nuclear because we have wind or solar?
Yeah, and I think that, again, these are not new technologies. Solar, nuclear, I mean, every time we have an issue associated with need more energy, there's a lot of policy pushed at it. You look at the early 70s with the whole embargo that occurred there, and people thought solar. And then there are issues, well, what type of solar? Well, and where do you need it? And are these water-rich areas where there may need it to have water for the solar? I mean, these debates have been going on for decades. But in the end, these require large amounts of space, and they require some sort of battery to ensure that you can store when there is less wind or when there is when there is sun's
Kind of
gone down.
hybrids.
Yeah,
Yeah.
and these battery storage facilities, fortunately, are getting better, but they still are very expensive. And do you want to in the end, do you want to have everything with the idea that we can store this rather than we can produce this continually? Nuclear can be produced continually. It's not like, okay, we're having a drop at this time of day or whatever it might be. It knows, and it can learn the system of, at this time of day, we need this amount of energy. And so it's not, it doesn't stop when you need it, and it can process and provide the amount of energy needed at times when the energy is needed.
If you're running a Western state, why should you care about nuclear?
I think a variety of reasons. I think the issue that everybody's talk about, it's a clean, reliable energy. And we see that in multiple states where you have a desire to have this type of energy around you. And in many cases, people thought that was only, solar energy, hydro, et cetera. But it does do a lot of good for the environment. Also, the growth patterns in Western states are communities that might be off of a normal grid or not where they can get electricity. So it does open up the capability to feed these communities that are energy short, and hopefully in the long term be energy, price efficient to where these communities have a reliable supply as they're growing. But the industry alone, I mean, I look at a state like Utah and a city like Salt Lake that has such a strong need for a reliable energy, well, just energy in itself for a lot of the facilities that are being built for advanced manufacturing, for data centers, for all the needs that we have in an office to use, AI and the amounts of data center capacity that's needed to do this. So, in the Western United States, a lot of these communities are growing quite quick, and people want to live in an area that has, you breathable air, and in this case, again, nuclear provides a mean to ensure that it's clean, reliable energy.
How would you, suggest to the local officials how they could evaluate the net benefits of a nuclear project?
I think it's really going to come down to safety and price. And if we can ensure safety, which we have decades of experience showing that large facilities are safe. We have now, in many cases, decades and even better data associated with some of these small modular nuclear facilities showing that these can be done in a safe manner, that you take the safety issue off and you can demonstrate that you can show easily with data that, look, by going traditional ways of energy production, these are some of the issues that are associated with that. And not that I'm not a believer in oil and gas and coal, etc. There are some limitations and there are some issues associated with air quality that some of these communities might see as being, ensuring that there's dual, parallel fuels being used. But in the end, when it becomes price effective and communities see that and see that these are safe and what they're getting out of it, I think most communities will clamor to see if they can have these built in areas where the utilities will want to put them to ensure that they have this reliable, clean energy.
What advantages does the Western Conference specifically have?
So I think in the West right now I'll say that a lot of the folks in these states are innovators in looking at the future of what and where we should be going with the direction we should going.
So let's switch over to association in the ecosystem now. So why did LSI launch the Nuclear Energy National Association, NANIA?
I think first and foremost is that LSI has been in this cluster, what I call cluster, bringing together multiple entities that care about something and putting them under an umbrella so they're working hand in hand rather than counter, or you can call it a hub, whatever it might be, with the expertise in developing unique clusters and hubs across the United States. It's very different than the traditional association that says, oh, you build nuclear, you should be a part of us. In this case, it could be so many different entities that want to be a part of this because they see how they're relying upon energy rather than just focusing in on, we have the smartest, most capable people in one sector. We bring together the smartest people in multiple sectors so that everything is going in parallel together.
So, and maybe you can tell listeners too, is that with these consortiums, some would say, why would you form this ecosystem? You're bringing competitors against competitors to the table, right? But we have done this with over the last 10 to 15 years with several different organizations in different industries. Why does an ecosystem kind of association of bringing everyone to the table really make it stronger and give them benefits?
Yeah, I think that, there's always the argument that, this competes or we compete with this other entity. I think if we can improve a process where multiple entities of different focuses come together, it just unites and makes it stronger. If you have multiple companies that care about technology situated in an area that may be competing, but they have a reliable energy supply at a cheaper cost, great. You have multiple facilities that are doing advanced manufacturing. Some might be doing it for defense purposes, some for recreation purposes, whatever it might be, but all coming together and being able to talk through all these issues together, it makes the industries as a whole stronger. And, I might produce gadget A and someone else a similar gadget, but because we can do it more cost effective and we're doing it in a manner in which we're learning as we go, we all benefit.
Yep. What are some of NANIA's near-term priorities?
First is to get the right people involved. And why, again, I think LSI has been a good player in this is we know that it's just not a nuclear scientist. It's just not a manufacturer of turbines or whatever it might be. It is multiple entities, and I think our first focus area is to bring under the umbrella different entities who should care about this that may never had even thought about clean energy or reliable energy, but recognize that in the near future they're going to have a reliable energy supply for whatever they may be doing.
What policy changes actually unlock progress? You've mentioned policy behind some of this.
Yeah, and I think that what we have seen, a lot of this gets held up in the permitting, the regulatory process. That we're not going to get rid of. But can we do things to ensure that as things are moving along, that each group understands what's happening and why? So rather than saying we have the next best design and now we're going to go forward, as we're creating the next best design, we are involving everybody in that. So it could be regulators, it could be policymakers, so that at some point that someone doesn't come and say, "Oh, but you need to do this." I've always believed that, and it's this 90% issue. You get 90% of people agree on a certain issue. There's always that 10% faction. When you can take 90% off the table and now you start to talk about the 10% of why this is why it's a challenge, you now are debating the real issues rather than mix and matching things that are causing headaches but not being productive. I think the purpose of this association is let's focus in very quickly to what's stopping these things from going forward, or this type of energy that we all agree to, and get out of the little this noise out there that is is disruptive, but it's resolvable. And if we can narrow it down to that 10%, which of course is getting into the cost issues, permitting issues, and ensuring that a technology actually works. I mean, last thing we want to do is be saying we have the next best answer to, and this is it, or we have the answer and this is it, is to be able to, under one association, ensure that all these technologies can progress together so that if one does, perchance, make sense and is cost effective and meets all the standards that we've been talking about, then we can go forward with that, not excluding others that are part of it that may have a different approach and the reasons why, but just to make sure that we're not stuck doing something for 10 years and then we're told by a regulatory agency, oh, you needed to do this. We want to make sure that that's done in parallel going through the process so that the 10 years doesn't become 40 years.
Okay. And I think when we explain to people on associations or these consortiums, clusters that we build, right, is we always take the simple form of like if you're building a bike, we're not just asking Schwinn what they think and what, their recommendations are. We're talking to the people who built the bolts that are like, hey, if you did this 1/10 of a millimeter smaller, it would save you 80 cents on the dollar to make it. And, we've done a lot in this space in advanced manufacturing and minerals with UAMI. And, where that actually has, not kind of like this bidding system now that's been set up where someone drops in, hey, I have this work order. I've got this task order. Who can build these? Who can make these? Who can do this? And in what time? So I just think that it's when you think about the whole sum of all the parts of that bike, it's bringing them all together saying, what's the best practices? What should governance look like, et cetera?
Well, I like that, even from a supply chain perspective. Let's assume that these are built off-site and they have a unique size to it. Isn't it great that you could have someone who is in the sector of some sort of advanced manufacturing or concrete, or a company that makes trucks or wants to develop trucks that could take that type of a load, whether it's the weight or the size, and move it. So this type of association is bringing in all these people because you develop this, you got to be able to move it. You call it modular. Well, are these off the shelf type of turbines that can be used or whatever it might be, or are we having to develop one-offs? And by bringing everybody together, the intent is we have the supply chain, so we're not dependent upon somebody else to move it, to build it, to provide this type of material. It's all included. And these are going to be different folks. I mean, right now, the folks who move stuff across the country, I would have them in the room as I'm developing the size and scope of what I call modular, and making sure that the trucks can take it, the trains can take it, the air can take it, whatever it is, and also be thinking that it's just not going to be a one-off, but there is a market for this, so that you have people who are willing to invest in the supply chain, and if these are built in specific factories, that they can move it from point A to point B.
Okay, we got a lightning round recap. One sentence, just to recap to listeners on this. Why is nuclear considered clean power?
It's releasing really nothing into the air.
Okay. Name one way nuclear supports economic development.
It allows folks who need energy and reliable energy to come to an area.
Okay. What's an SMR in one line? Small modular reactor.
It is a product that can be delivered and provide energy for the needs of communities from 200,000 people below and above.
Okay. final takeaway, what should a skeptical listener know?
That nuclear is safe and reliable, and will be hopefully in the backyards of many of us throughout the country and world in the next 10 to 15 years.
If this conversation sparked ideas for your state, utility, tribe, university, or company, how do they engage with us, right? Where can they find out more about the association or become an NEM member?
So the easiest way is just our URL. Our website is Advanced Energy Hub. We're not calling it
.org.
Yeah, .org.
Yep.
Sorry, Advanced Energy hub.org. And again, it has hub because of what we care about is all parties engaged, not just the smart nuclear people that are required or engineers that are required, but everybody's engaged to make this a hub of excitement rather than a process in which very few hit each other on the back and talk about, great move in this area. It's now having everybody under one roof.
Great. Josh, thanks for joining us today to educate us on nuclear and, all the LSI is doing in that space. Appreciate it.
Thank you.